your progress, and I would give you frequent feedback on how you are doing. And so that's how I'm going to conduct the course. And about the content of the course, give me just a second. Yeah, about the content of the course, just in a nutshell. Uh, oh, the structure. Maybe I should talk about the structure first. So for math, there are two sections. Okay, you might know about this already. So the first section has 20 questions, and you have 25 minutes to work on them. So a little over 1 minute per question. And calculator is not allowed for this section. And the second section has 38 questions, and you have 55 minutes. Okay, so close to 2 minutes. Okay, under 2 minutes per question. And some of these questions, the reason why more time is allocated on the average per question on this second section is because some of the questions are a little involved, and calculators are allowed for this section. So that's roughly, so we are talking about 25 plus 55, 80 minutes, okay, altogether of math. That's what you see in SAT. And about the content of the exam, very broadly speaking, there are two areas, okay, and one area would be algebra, and algebra is a predominant area of SAT. So when I say algebra, I mean, all the usual stuff, like equations, solutions to equations, both linear and quadratic, systems of equations, solutions to systems of equations. And although these come across as rather straightforward, there are quite a few tricky questions that get asked in algebra. And these have to do with, when does a system of equation or an equation have a solution? Okay, so that's a tricky area of SAT. And today, when I give the math demo, I intend to be more, I mean, that's one of the topics in my mind for the math demo. So I would be more explicit about what I mean when I say that, when I pose this question, that does a system of equation have a solution? Does a single equation, a single linear equation in one variable, does it have a solution? Does a quadratic equation, how many solutions does it have? Well, it has two, but then, there are trickier versions or trickier contexts in which it turns out that it may have more than two solutions. It may have an infinite number of solutions. So, so that's applicable only in a rather tricky context. So, so that's algebra, just to give you an idea. And aside from algebra, the other predominant area would be functions and graphs of functions. Okay. And the third major area would be statistics and data analysis. Okay. And data analysis, when I say that, like, you'll be given all kinds of graphs. You can have line graphs, you can have scatter plots, bar charts, and so on and so forth, histograms. And these data analysis questions, they draw upon your knowledge from two areas primarily. One is stats, mean, median, mode, standard deviation. And the other area is functions. Okay. So, so roughly speaking, let me actually, so the predominant areas that I talked about, one is algebra, then we have functions. Okay, so we have stats, and these two feed into data analysis. So data analysis indirectly tests your understanding of functions and stats and more. Naturally, you need to be able to, get a good feel for various kinds of graphs that there are. Okay. And outside of this, there's, I would just call it miscellaneous. There's a splattering of, like percentages, exponential growth, and, geometry, of course, but I won't say geometry is a predominant, like, topic. So out of these 58 questions, 20 plus 38, out of these 58 questions, maybe 3-4 questions would be on geometry, not more than that. And then, you would have complex numbers, trigonometry, maybe you can expect to see 1 or 2. questions on complex numbers and trigonometry. So, so there's a splattering of, like miscellaneous topics, but these are the key areas of SAT. Okay. So I believe that's all I wanted to say. Oh, yes, just one other point that I would like to make. Now, these 20 class hours that I mentioned, so these can always be customized, depending on the need of the student. So in 20 hours, it is my experience that, one gets to cover quite comfortably everything that comes, all the entire curriculum for SAT. And after that, what I always recommend my students to do is take practice tests. Okay. And then when you are taking these practice tests, naturally, let's say you take 3 or 4 practice tests and you would have doubts, and then we can have additional sessions where, the whole objective would be to clear the doubt. Okay. Okay. So I think that that finishes my presentation. And, if you don't have any questions, do you have any questions on what I just said?
No, not really.
Okay. So I will, pass the pass on to Brotin.
Sure, thanks, Abhijit. And let me just pass to Alokendra to. So the structure would be Alokendra would give you an overview of the English, and then we'll have the English session for roughly about say 45 minutes, and then we'll come back to maths, and Abhijit will take the actual math session. And the key point which is stressed, like all of you who have maths in your high school, you have covered a lot of the topics, but I think the main thing what we will show is there are a lot of areas in SAT which may not be covered in detail during your high school maths. So those are the areas we'll try to focus on. So with this, Alokendra, over to you.
Okay. Thank you, Brutin. Good morning, class. As Brutin mentioned, my name is Alokendra Mitra, and I'm also a trainer. I've been a trainer for almost a decade now. Not as long as Abhijit sir. He has a very long experience, but I've been teaching for 10 years. I primarily train for GMAT, SAT, GRE, and also the CAT, which is the Indian B-School examination. My background is in engineering. I have a BE in electrical engineering. I'm a CFA, also have a master's degree in quantitative finance, but I like teaching quants and also verbal primarily for SAT. Now, without further ado, I will delve into the structure of the test. Okay, so you can follow the screen that I have up here. I'm sharing the screen from another idea, Alok sir. The screen is being shared. So as Abhijit sir mentioned that maths has 2 sections. There are 2 sections. One has calculator involved, other doesn't allow calculator. Similarly, in language, you have 4 sections. You have reading, 2 sections, reading and writing. Okay, these 2 together will bring your score of 800. Okay, verbal score of 800 composes of 2 sections, the reading section and the writing and language section. Okay, so that I am sure most of you are familiar with. Any questions, class?
No.
And no questions, right? Okay. If you have any doubts, feel free to ask. Okay. So oftentimes students have doubts about this particular part. Okay, the cross tests. The cross tests can come from all 3 sections: maths, the 2 math sections, and the 2 sections in verbal, reading and writing and language. Okay, and these are subscores. These come from your reading and sections. Okay, so it's clearer if you come here. From writing and language, you have expression of ideas and standard English conventions. This is a very fancy way of saying grammar. Okay, when they say standard English conventions, all they mean is grammar, the English syntax. Okay, the English language, the words they use, vocabulary. Vocabulary is words in context, which has been very simplified. As Abhijit sir just mentioned, the SAT format was changed in 2016. So previously, you would have a sentence bereft of any context, and you would have a blank, and you will have to fill in the blank with a few options. Okay, a few options in the which are given. So you would be expected to know words like, let's say, let me give you a word. Do you know this word? Nation. Anybody? Students? Nandini? Am I audible, students?
Yeah.
Sorry, sir, I don't understand what you've written.
Yeah.
Like,
Okay, you don't understand.
is
Okay, I'll
that
just do it again.
notation?
No, Natation, not notation.
Oh, I'm not.
Notation or natation. You're not familiar.
I'm
Okay.
not familiar.
So in the previous format, okay, in the previous format, the SAT would have expected you to, and the GRE still expects you to know this word. Okay, it means swimming. It is essentially a French word used fancily in English, but the new SAT doesn't expect you to know these words. I will show you a test paper afterwards, and there you will find the words are to be tested in context, as they have seen here. Words in context. So there is a typical, very easy way of understanding the meaning of words in context, which we will, of course, delve deep into during the course. Okay. So I will give you an overview of the questions that are asked from here. Words in context, command of evidence. Command of evidence in reading and writing essentially means they will ask you a question and you have to answer the question. They have a paired question. So a question has been asked and they will ask you based on the passage, what do you think? And then afterwards, what they will ask you is, they will say, from which lines did you conclude this, reach this conclusion? So these questions come in pairs, and if you get one question correct, you will get the next one correct. If you don't get the answer correct for the first question, you will obviously find the wrong evidence for the lines in the passage for the same answer. Okay. So I'll show you those questions, but let us first give you an example of a normal class, what it should be like. Okay. Now, can you please look at the sentence and tell me which one I shall choose here? There are two options. It's a very simple English sentence, not very complicated.
Has.
Has. And Nandini? Nandini, are you there?
Hello?
Yes. What should the answer be? Options here?
Has.
Has. Both of you have said has, right? So let me just mark this with the blue first, okay? Or maybe green. Let's mark this with green. You have said has, okay? Why have you said has? Can you tell me? It's a very simple question. On the SAT, this will be all this. Why? If you're saying this is singular, you're saying it is singular. Yes, has is singular, have is plural. Which one shall we use?
Singular, because
Singular. Yeah.
Why? What is this? How do we determine this? It is called SVA, right? Subject, verb, agreement. Okay, it's a very fundamental and foundational topic. So on what? Agree on what? Agree on the number. So you have to find the agreement. Both of you have said has. Let me just delve deep into it. So how many verbs do we have in this sentence?
one
How many? One? Which one?
appeared, maybe.
Appeared. This whole thing, yeah, appeared, has appeared, have appeared. This is a modal verb. And another verb, there's another one. Think about it. Is not a verb. It is, right, Nandini, Vidushi?
Yeah.
Yeah.
So we can decompose the sentence into two parts. I'm trying to show you how grammar works, okay? So we can say some Hollywood actors, age actors, have appeared on Broadway Hugh Jackman is one of them, right? Did you understand what I'm saying? So by combining those two sentences, we can say Hugh Jackman is one of those Hollywood actors who have appeared on Broadway, right? Did you all get my question?
Yeah.
Yeah.
It's very simple. It's a very simple question, but you have to try and analyze it in this manner. That is where you need a new perspective into looking into questions. Okay, I have two new sentences, and these are all very SAT-like questions. Okay, these are very. I cannot use actual SAT questions right now because the SAT comes in a full passage. Okay, so it's a full passage, and you have 7, 8, 10 questions based on the passage. So that in a demo class is not possible, but we'll do that later. But these are very close approximations. This sentence, same concept, subject, verb, agreement. On the SAT, you can expect out of, in the writing and language section, out of 44 questions, you can expect 5 or 6 at least from this one. And if you combine this with pronouns and punctuation, 10 questions, maybe more than that. Nandini,
Is it crepes?
can you tell me? Crepes?
Is it
Why?
crepes?
If it
Yeah.
is crepes, why is it? Why?
It's singular
Explain to
again.
me. Which is your
Because-
subject of the verb?
New generation.
Excellent. New is an adjective. This is not your subject, part of the subject, but this is your subject noun. Generation. What crepes? A generation of. This is a prepositional phrase, a qualifying phrase, and this is again offset in commas. Creeps up every year. A new generation creeps up every year. Okay, we will do a lot of sentences and questions regarding this kind of examples. Number 2, second sentence.
Choose from second section.
Hmm?
What are
For the
the
second one, I have not indicated. There are no options. You have to correct it yourself. I want to see how well you can do it. How strong your fundamentals are. Identify the verb first.
Sticks.
Hmm?
And then purchase.
Sticks is a verb.
Sticks. Yeah, right.
You're saying this is a verb. You're saying this is a verb. Okay, let me mark it here.
Is that wrong?
We will come to that. See,
And
I don't like
purchase.
to use the word right and wrong. I prefer
Okay.
to use correct and incorrect. Purchase, yes. Okay, you're saying purchase, to purchase. Okay, you're saying this, right? Okay.
Yeah.
No, none of these are verbs. Sticks is a noun. Apple and cinnamon sticks. Apple stick, cinnamon stick. It's a noun. It is not a verb in this case.
Oh, sorry. I
And we
didn't.
have
I didn't
two
read that.
purchase.
My bad. Okay.
Okay.
the
Sorry.
verb would be
And
cause.
to purchase. This is a yes. This is a verb in the infinitive form. This is not a verb usage here. To purchase is a verb, but I don't say to purchase. I to purchase. I purchased, or he purchases. We purchase, right? So we do not use the verb to purchase in a sentence. We have to change the verb, right? I purchase. He purchases, right? So the verb form has to change. This we call conjugation, but not necessary to know the word. So this is not a verb here. What is a verb?
Causing.
What happens? What is the action here?
Causing.
Causing is also, no, it is a gerund. It is not a verb here. This is also not a verb.
Permeate.
Permeate, yes. What's the action? See, again, if to use causing, to use a ing form, the present participle of a verb, you always have to have an auxiliary verb. Am causing, he is riding, I am riding, right? You cannot say he riding, she riding, he writing, I eating. You have to say I am eating, right? So you cannot use a present participle without a helping verb like the auxiliary verb. So the verb here is permeates. We have finally come to the verb, permeates. In the examination, you have to practice before the examination so much. You will have 35 minutes to answer 44 questions. Okay, 35 minutes, 44 questions. So you have to drill, and I will in 20 hours, as Abhijit sir mentioned, we have a 20-hour course structure. After 20 hours, these things will be very easy to use. Like there will be no problems at all because we have structured exercises, and of course, all the past tests and everything I will give to you. Don't have to worry about that at all. No material you have to worry about. All the tests we have. So look at the question. Look at this sentence first. Permeate. So what permeate or what permeates?
The scent.
Scent. So is that singular or plural?
Singular.
Singular. Very good. So this is singular. So what shall we have here? A singular verb, right?
So should it be
Yeah.
permeates?
Permeates, yes. This is the very funny thing is that when you have a verb in the singular in the present tense, the verb ends with s. It's a singular verb, right? And if we have a plural noun, the noun ends with s. And verb, singular verb ends with s. That's the primary distinction. Did you understand?
Yep.
Let us move to our next sentence. Let us look at these questions and tell me if you think, whether you think anything is wrong in these sentences or not.
In the first one, I don't think it should be its. I think it should be a sequel.
It should be
A sequel.
a
instead of-
sequel, okay? You are saying, okay. You're saying a sequel, very good. That is an option that you have mentioned. I will note it. This answer was given by Nandini or Vidushi?
Fiduci.
Vidushi said a sequel, okay. Nandini, any options you think of?
I wouldn't necessarily say a sequel. I think its sequel is also right.
Okay, anything else?
Not too sure.
Yeah, I'm not too sure about this.
Nothing, right? Okay. Okay. Good. So no, this is a pronoun. What does it mean?
Possession of something, owning it, or like
Yes.
it belongs to the other.
It's sequel. Sequel of what? Yes, correct. Sequel of what? Of the novel?
The first novel, yeah.
Novel, yes. So in this sentence, let me put it this way. If I say that the error is of the pronoun, there's a pronoun error. Can you tell me what the pronoun error is? Okay, let me again tell you that for every pronoun, the antecedent, the word, the noun the pronoun refers to has to be previously present in the sentence. Okay. I'm telling you that every time you use a pronoun in a paragraph or in a sentence, here we have a sentence, the noun that the pronoun is referring to has to be present. So with this information, can you correct the sentence? Anyone? Identify the pronouns in this sentence.
Jane.
Jane.
Oh, that's a proper noun.
Novel.
Okay, so you were saying Jane's a proper noun. Novel is a pronoun.
Yeah.
What is a pronoun? A pronoun is something that replaces a noun, substitutes a noun, right? Novel is a noun.
Yeah.
It's a common noun. And Jane's here is not a proper noun. We don't have Jane. We have Janes. Jane can be a proper noun, right?
So does James become a pronoun?
It becomes a possessive. Yes, possessive. It's not a pronoun. It's a possessive
Okay.
thing. So you
Okay.
possess Jane. Both of these qualify the novel. Pronoun it's a adjective possessive. Okay. So novel here is your what was well received. The novel was well received. Yes.
She.
What novel? James's first novel. Yes. So she is a pronoun. Very true. Correct. She is a pronoun. Then
And it's.
it's very good. So what did I tell you? That if you have a pronoun in a sentence, you need to find its antecedent noun. Yes or no?
Yep.
So do I have the antecedent noun of this particular pronoun, she, in this sentence?
Yeah. Jane.
But I don't have Jane, do I? I have Janes. I don't have Jane in this sentence. There's a huge difference. It might not seem much to you, the difference between Janes and Jane, but that difference is the determining factor in this sentence and in many other that sentences. You will have, I'm telling you, with pronouns clubbed with punctuations and subject verb agreements, because pronouns can also come in subject verb agreement. Pronoun can be the subject. If it replaces a noun, it can be a subject. So pronouns, subject verb agreement, and punctuations will give you, out of the 44 questions, at least 10 to 12 minimum, very easily. So you shouldn't take this lightly. If you understand this concept, you get 2 questions correct. James is not your it's not a noun. A pronoun cannot replace an adjective, it cannot replace a verb, it cannot substitute for anything but a noun or a noun phrase. It's not a noun phrase here. Novel is a noun. You have it's here for the novel. But she cannot refer to pronoun. So you have to change the sentences by Jane. In the exam, you will have the 4 options there. You can scan the options. Scanning it's a technique we will teach you in the class, in our classes. So it's easier, but you need to know the concepts. Next question. Look at the next one, please.
Sorry, what's the correct answer for the first one then?
Jane's first novel was so well received that Jane thought of writing its sequel.
But then wouldn't that be repetitive?
There is no repetition here. Grammatically, there is no repetition. Repetition is a stylistic question. Okay. But we cannot repeat because what we don't have, you cannot repeat. You understand that? What you do not have, you cannot repeat it. To repeat it in the first place. We have Janes grammatically speaking, they're different parts of speech. Jane is a noun and Janes is a possessive. You understand that?
Yeah.
So grammatically speaking, you're not repeating yourself. Next question. This one is correct because I have heard here, pronoun here. It's adjective, pronoun, possessive pronoun. So we have her here, okay? This is correct. Her, and the difference between her and she is this is a subjective noun, nominative pronoun, and this is an objective pronoun. Okay, that we'll also cover in class in detail. Look at this one. The first sentence.
Is it in the first one, is it adding words, or is it just like correcting or replacing words?
You can add words, yes. You can add words. You can add words. You should add words actually.
I think that should be a the between by and British. So I think it should be by the British author J.K. Rowling, and
Okay, that's a good point. By the British author, very good. That was, but that is not the error I'm looking for actually. Okay, yeah, that's a good point. Thank you. That's a.
and is it also punctuation marks or no punctuation marks?
No, there is no punctuation error. There are no punctuations error.
And I think that should be off between record and 8.9. So sold a record of 8.9 million copies.
No,
Yeah, I
no,
was
no,
gonna
no,
say
no,
that.
no,
Yeah.
no. That is not niche. You don't need a preposition here. I sold a record at 10 bagels this month. It's not a preposition. Is not required. You can add it. It's not called for. It's not necessary. Compulsory.
For
It's a
after
different.
24 hours, it was on sale. We can replace it with
Okay.
off its sale.
24 hours.
So after
After
24
its
hours,
sale.
off its sale.
Okay. But was it sold once at one go? It is being sold continuously, right? Discreetly. One book is being bought by Vidushi, one by Nandini, then one by Vijit sir.
Okay.
Then another by Brutin sir. Right? Don't buy it. No, that is also not an issue. The next question, the next one. Both of them have the same error. The next one. sorry.
Is it the pronoun that's not correct? In the second one?
Oh, there is no pronoun. See, this is a less of an English question, more of a logical question. You will see in the English section, as Obijit sir mentioned, you have data interpretation. We also have graphical interpretation questions in the English section. I will show them when I look at a paper with you after some time. Okay. So if you look at this set, the next question is easier to explain. After being tutored at Edu Infinite, Odija is in her class. Okay. Okay. So let these be all the students in her class, right? So can she score more than any student in her class or more than any other student in her class?
Is it because
Right.
she would be included in the
Here,
NP?
this is a set of elements. She's a member of this set. She's a student in the class. So she cannot score more than any student in the class. She has to score more than any other student in the class. And J.K. Rowling is also an author. She is not out of the group of authors. When I say any author till date, it includes J.K. Rowling. So I have to say any other which come. I have the entire errors classified, and we will cover all of those slowly and steadily. This new one, can you look at it?
Immediately would come towards the end of the sentence, right? A new bonus scheme was announced by the manager immediately.
No. You see, immediately is here. It's an adverb,
Okay.
right? So adverbs in general come right next to what they're modifying. Here they're modifying the verb. When was it announced? Immediately announced. You could argue, okay, not on the SAT, it is not an error that is penalized. On the GMAT, it is penalized. By splitting was announced. Okay, stylistically, some people frown upon it. So you could say that announced immediately, but not after manager. That is not absolutely not acceptable. You could say was announced immediately, but that is not an error I'm looking at. It's not something is tested on the SAT, not a SAT question.
Is it about like rephrasing the sentence, how the sentence could be written better?
You have to rephrase it. Yes, you have to rephrase it. See, on the SAT, we have many questions that come from something called misplaced modifiers. What's a modifier? Something that is qualifying something. There's something called run-on sentences. This sentence sounds and looks perfectly okay to you. On the SAT, in the passage, you will find a sentence like this. And then you will find a question to the right of it, on the right side of the questions. The first option will be no change. And then you will have three options. So you have to choose from them. Where is the error? But without looking at the options, you need to find the error. So what is a modifier? Modifier is something that modifies, that qualifies, gives you information. So overjoyed by the quarterly results. Who is overjoyed? The bonus scheme? The manager, exactly. So the person who is overjoyed is the manager. So modifier has to be placed right next to it, or at least as close to it as possible.
Yeah.
To the word it modifiers. So you have to change the system. Overjoyed by the quarterly results, a new bonus scheme was immediately announced to the managers to say, overjoyed by the quarterly results, the manager immediately announced a bonus scheme. This is also a very common error, okay? Quarterly results. Okay. Next one.
Should it be after instead of upon?
No.
I can't see a screen.
Okay, just a moment. You couldn't see my screen, right? Okay. There is a technical issue here. Just give me a moment. So the question was, upon receiving the leaving the counter, what was the question? That sentence, just a moment. Okay, so we are back where we were. Is my my screen is visible? Okay, yeah, my screen is visible now. I'm back. Upon leaving the counter, the cashier handed the customer a receipt. Okay, how do you rephrase this? Who left the counter?
The cashier.
No, the cashier
The
stays in the
customer.
counter. The customer, very good. So you have to say, upon leaving the counter, the customer was handed a receipt by the cashier. However, on the SAT, you should always prefer active to passive. Okay? On the SAT, you should always prefer active to passive. So if you had two options, one option said, upon leaving the counter, the customer was handed a receipt by the cashier. Okay, then that is not better than that is the cashier handed a receipt to the customer when he left the counter. Okay, so you have to prefer active to passive. Going to the next question. Any questions?
No, it's okay. I understand now.
Okay, these are three questions you have here. Always remember that on the SAT, you might have two options that are grammatically correct, but one is passive, one is active. So prefer the active to the passive, and always go for the concise and precise option. Concise means smaller, shorter, and precise means to the point. Okay, these are concepts which are tasted. These are subjective matters, but they are also asked on the SAT. So that is if you look at any SAT book, you will see they have chapters on this as well. You will give you entire materials on this. This one, 3 sentences. First one, do it.
Is it where millions of people are still suffering from food shortages caused by last year's infestation? The International Red Cross
Where
announced
is
today that a swarm of locusts have invaded southern Nigeria.
okay? What's there? Where is the what? How are you restructuring the sentence?
Sorry?
How are you restructuring the sentence? Where is the error?
Oh no, I just turned into passive, right?
No, yeah. See, even more than passive, if you put this first, where millions of people are still suffering from food shortages caused by last year's infestation, then you say IRC announced. But this phrase does not modify the IRC, it modifies Southern Niger. Right. This country is called Niger, and it's not Niger, it's Niger, okay? It's a French colony, they pronounce it Niger, and right next to Nigeria. Both of them are named after the river Niger, okay? Niger River.
Okay, so would it be then the International Red Cross announced
So
today a swarm that southern Niger, where millions of people are still suffering from food shortages caused by last year's infestation, was invaded by a swarm of locusts?
okay, by changing the structure, you have eliminated the error, but you have not understood why you have eliminated the error. You have not actually identified the error you have eliminated. You have restructured the sentence. Perfectly okay. Announced and was invaded. You put both. Was invaded is the past tense. Was invaded. So I have to say in the present perfect tense. This part. Announce. Find me the verbs in the sentence. The verbs here.
Have invaded and suffering, still suffering.
Okay, still suffering, are suffering, not still suffering, are suffering. Okay, by the no, sorry, yeah, have invaded. Who announced? IRC announced in this case. What have invaded?
The locusts. I just have a question. Does the error have anything to do with the fact that the invasion here is mentioned in present tense?
See, this is a subject-verb agreement error. Yes, this is a SVA error. So to change the verb. In the past, when you restart the sentence, you said was invaded. Okay, so was is one verb. We don't have a plural or say singular for was. So by putting it in the present tense, I have highlighted an error which is in the subject-verb agreement. Okay. So there is no, the to be verb. This verb is a to be. Okay. In the present tense, you can say is, you can say are. In the past, you can say was and were as well. Okay. So when you put it into was invaded. Okay. You said was invaded by a swarm of locusts.
Yeah.
Right. So you change the subject and verb. You change the subject, the verb and the subject altogether. So change that relationship. You move it away. But here we have highlighted that. Okay. So this is the verb where the error lies. This is a verb where your error lies. But why is this erroneous? This will be has invaded. Why? You said your subject is locust. Subject is not locust. Subject is a swarm of locusts.
Oh, is it because it's
It's
singular?
a collective noun. Yes, this is a singular noun. A collective noun is always a singular noun. A collective noun is never a plural noun. Collective nouns being singular nouns, they will take singular verbs. So you have jury, you have crew, faculty. Okay. So we always say faculty. The faculty are in a meeting. The faculty are not in a meeting. The members of the faculty are in a meeting. The faculty is meeting now. The faculty is singular. Members of the faculty are plural. When we enumerate the members individually, cabinet. The cabinet is meeting. The cabinet in the Union cabinet is meeting. The cabinet is singular. The members of the cabinet, ministers who are members of the cabinet. When it's the members of the cabinet, they are plural. Army is singular. The Senate is plural, singular. Senators are plural. Okay. So this is a very common concept. This is something which is tested very often, and you will see that people who don't prepare for the exam systematically, they make a mistake. These are common errors I'm highlighting. Okay. Next one. Very simple sentence.
Is there any problem with the first word? Instead of a, should it be the?
No. That wouldn't change anything, and it's not a problem.
Isn't that passive?
Is it not? It no.
Is
It
it
has
passive?
something has led to. No. That's not an error here as well. It's not passive. This is not the error I'm looking at. This is also a SVA error, subject verb agreement.
Should it also be here has instead of have, because this sentence starts off with a, implying that it's singular?
Yes. Okay.
Should it be has instead of have?
It should be, but why?
Because
Why?
the sentence starts off with a, and that is
Yes.
implying that it is singular.
Okay. But is that the reason? A, shortage of dentists. Just that. If I say a boy. Okay, let me look at the next sentence. Let me look at this one. These two sentences. I have all the traps ready for you. This is normally I am mixing and matching different errors, subject, verb, agreement, pronouns. But in the class, one day when we do SVA, we will complete SVA and pronouns in 2 days, along with punctuations. Also, we'll do that in 2 days, okay? And then you can do a third of the SAT reading and language question, writing and language question. Look at these two sentences. What's the difference?
I
The
think
first one is
off.
yeah, sorry, go ahead.
But I mean, I'm pretty sure it's a trick question.
Okay. But I have two questions here, two sentences. See, all the elements are the same. I have just changed the position of the professor and the student. The professor as well as the students. Yes?
When I read it out loud, it doesn't really sound correct to say is. So, I mean, both
Which
of them are plural when you combine subjects. So, I think both of them should be are.
Okay.
Sorry,
So
I would say
Nandini
the
said
first one.
when
I would say the first one is because the first one is professor and the students are inclusive and are a member of that part, and the second one will be are because students again is a plural and the professor is inclusive under
okay.
that.
Okay. Nandini, excellent, well done. Thank you. Very good answer. This is a question of a compound subject. Okay. What is a compound subject? Compound subject is when you add multiple nouns or subjects together and make it a plural subject. Singular subjects joined together to make a plural subject. And is the only conjunction which makes a compound subject. Okay. Anything else? No. So whichever thing you have at the beginning of a sentence is your subject. The professor as well as the students are in the classroom. No, is in the classroom. And then you got it correct. The yellow is for you. And the students as well as their professor are in the classroom. The students are the subject here. Okay. Got it?
Yeah.
Both of you? So keep this in mind, because we will come to, when we do the class, we will also have either or, neither nor, okay, many other kinds of conjunctions will be there. So they will have different rules for each of these. Okay, now look at this sentence. A shortage of dentists. As well as, this is offset by two commas, being offset by two commas, and with the phrase as well as, this does not make it a compound subject. Okay, so your subject is shortage, has led to widespread oral health problems in the state. Next question.
Should it be lies in events instead of lie in events? Because today's economic crisis is
Lies, yes,
singular.
lies. The subject is cause. The cause lies, right? Next one. True. Any doubts here? Students? No doubts, right?
No.
Okay.
Nope.
Okay. Let us look at this question.
Should it be is instead of was?
Past tense, that's tense. That is a different question. Tense also features, but not so much. Is and was past tense. Whether it was yesterday or it is today doesn't make a difference to me. Okay, let us do something. Look at a proper SAT question. Okay. Let us look at this question here. This is 2021 May SAT paper. Okay, this question came in this exam, the one that was on the 8th of May. Am I still online?
Yeah, but I can't see your screen.
Okay, I have to reshare it. I think there's some issue here. I think there was some. I got disconnected. Just a minute. Okay. This is a actual SAT question. This was this is a passage part. I will show you the paper later. Question 23. This is the May 8th paper. Okay.
Is it R? C for 23?
Why?
Because
Why?
four differently sized rectangular prisms make them all distinct from each other. So it's a plural.
Yes, prisms. Yes, prisms makes it plural. Are.
Yeah.
Very good. Look at this one.
Were.
So in the bag,
Whoa.
were
Were.
yeah.
Exactly. A pen and a bottle of ink. Sorry. Were. Sorry, excuse my handwriting. It's getting bad to worse these days. A pen and a bottle of ink were in the bag. This is an inverted sentence. Look at this is an inverted sentence. I have another example. What should it be?
Are.
Okay. What are around the corner?
The bakery and the supermarket.
Exactly. A bakery and a supermarket are around the corner. Okay. Now let us go to a May 2021 International Saturday. Let us go to this one. I'll just show you one or two questions and then let you be. I will hand you over to our quants faculty, Ovijit sir. He's an excellent faculty. Okay. Sorry. Just give him maybe. Just a moment. Okay, sorry, this is not this test. Give me a minute. It should be this one. Oh. Just a minute. Okay? Sorry for the inconvenience. I had by mistake uploaded the US test, the international one. I'm doing it now. Look at this question 2. Question 1 and question 2. Look at both of them.
I'm sorry, but
So I can't see your screen.
yeah, me either.
Okay, just again we got disconnected. Wait, I am not connected from that site. Am I connected now?
No.
Just a moment. Okay, I have reconnected, I think. Okay, I have reconnected. Okay. Can you see it now? Question 1 and 2. Students? Students, am I audible?
Yeah,
I'm
you're
Am I audible?
Yeah.
Okay. Question 1 and 2. Look at question 2 first. Look at question 2.
I think for question 1, it's no change, and for question 2, it's them.
For question 1, you're saying no change, and the other answer.
I
And
have a
any other
slightly
options?
different
Anybody?
one. Yeah, for me, I would
What?
say the first one is D and second one is B.
First one is D. Yes, and second one is
Yeah,
B.
them. Yeah,
Okay.
that's my answer.
Very good. So, okay, so them. Them is both of you are correct. Why? Because this is a pronoun. This is a singular pronoun. But what is the noun it refers to?
Corals.
Corals, plural. So you should have them. Very good. Now this one is a punctuation question. This is a slightly complicated one right now, but I will tell you that this is a independent clause. Some plurals are
Yeah,
fluorescent independent clause, right? This means that they absorb one color of light and emit a different one. Another independent clause. Two independent clauses cannot be separated by a comma. They cannot be separated by a comma unless they have one of those coordinating conjunctions called fanboys with them. Okay. So there are ways of joining two independent clauses. So you cannot join them in that manner. But here they have not given that. The options are not punctuation options. Okay, this question can come also as a punctuation question with semicolons and stuff like that. So it should be D. I will explain to you later why D it is D. Why this is not the answer? Because both of them are independent clauses. They cannot be separated by just a comma. Okay, we have just a comma here. They cannot be separated by that. That is an error. Okay, just show you some questions. Okay. Okay. So I think I will. The other question that I showed you in the other file was also taken from this test. Okay. So I'll just hand you over now to Abhijit sir. Do you have any questions, students?
No.
Any questions? Any doubts? Anything about the SAT paper pattern? Sure.
yeah.
Yeah.
Okay. Then in that case, I will hand you over to Abhijit sir. Okay. I will mute myself
Well,
and I will be online.
Yeah, before I come
Thank
on,
you,
like
Abhijit, sir.
Brutin, did you have a word to say? You want to come on? I'm asking Brutin. Brutin, did you want to come on? Okay. All right. So what I would do is, as I start, by the way, am I audible? Can you hear me?
Yeah.
Okay,
Yeah.
wonderful.
Yes,
And
sir,
the
you are audible,
whiteboard,
sir.
I believe, is visible. Okay. So let's get started. So what I intend to do today, just a second. I think I can make let me adjust my phone a bit better. Okay. Give me just a second. Okay, that's better. Okay, so what I wish to do is to introduce you to a topic which is very much a part of SAT, but it doesn't really get covered under a usual regular high school curriculum. Okay, so there, just so you're aware, there are topics such as this. Okay, not a whole lot, but there are topics such as this that are very much part and parcel of SAT, but it doesn't get covered under 11-12 curriculum anywhere, perhaps in the US in some schools, but generally, not in Singapore, not in India, which is where I'm, currently stationed. So we are going to look at one such topic. Okay, and see, I wish I could describe the topic for you right now, but then you just need to be a bit patient, because I can tell you what the topic is about, but it's unlikely it's going to make any sense to you. Okay, so once we, like within the next 10 minutes or so, I should be in a position where I can tell you, like a description of this topic. I can tell you what the topic is all about. But broadly, the topic is about linear equations. Okay, so I'm sure like both of you have seen what linear equations are. So let's just take an example. A linear equation, a simple linear equation would be something like this: 3x equals 5. Okay, and this is a linear equation in just one variable. Okay, now you can also have linear equations in two variables. Okay, what would be an example? Say 2x plus 3y equals 12. So that's a linear equation in two variables. You can have a linear equation in three variables. Okay, 2x plus 3y plus 5z equals 7. So that's a linear equation in three variables. Okay, now there's a good reason why the word linear is used in the context of these equations, why they are called linear. So we are going to get into that shortly. Okay, but before that, let me mention to you that a characteristic of linear equations, be it in one variable or two variables or three variables, is that these variables are always raised to the power 1. They're always raised to the power 1. So for example, if you take an equation that involves only one variable, okay, this one, okay, so here x has been raised to the power 1. Okay, now if you consider an equation involving one variable where the variable is raised to the power 2, that's the highest power of the underlying variable. Okay, so what would an example be? 2x squared plus 5x plus 7 equals 0. So the highest power of the variable is 2. Then what do we call this? There's a name for this. These are?
Quadratic.
Yes? I'm sorry?
Quadratic.
Quadratic equations, exactly. And now if the variable is raised to the power 3, cubic equation, and so on and so forth. Okay, so linear equations are very special. Okay, whether linear equations involve one variable or two variable or three or more than three variables, and it's possible you can have n number of variables where n is an integer. Okay, so all the variables must be raised to the power 1. Okay, so that's the definition of a linear equation. And as I mentioned, I'll come shortly to the topic of, or to the reason why these are called linear, as opposed, why that name linear is chosen to describe these. Before I get into that, let me ask you a rather simple question. It is that, let's take a linear equation that involves one variable. Okay, and the general form, so a specific example is 3x equals 5. General form is ax plus b equals 0. Okay, how many solutions does this equation have?
2. No, just one.
Just one solution. Did someone say 2?
Sorry,
was
I
that?
accidentally said 2.
Okay, so
Yeah, I said 2 as well.
Who said 2?
I said 2, but I corrected myself.
Okay,
It's just
okay,
one.
all right. Yeah, it's understandable. It's a Sunday morning, time to possibly take a break from life. And So your mathematical faculties may not be at its sharpest, but that's quite okay. Yeah, it has one solution. Okay, linear equation involving one variable has one solution. So now let's take the case of, let me erase this. Now let's consider a linear equation that involves two variables. So let's take 2x plus 3y equals 12. Okay. How many solutions do you think this has? Any guesses?
Would it be
2x plus
2?
3y equals 12. Yes,
Would it be 2? Or
two solutions.
yeah,
Okay, so is that Vidushi? Vidushi thinks there are two solutions. How about
yeah,
Nandini?
'cause for x and y.
Sorry, can I see the question?
Oh, I'm sorry.
You
Yeah,
can't solve that.
you can't solve that. Okay, so we have two answers. One answer is that there are two solutions, and the other answer is that you cannot solve that. Okay. Now the second answer, now both answers are incorrect. Okay, so I'll get into it. I'll get into the reasons behind it. But let me also mention to you Nandini's answer that you cannot solve that. It's a very popular answer. Okay, so whenever I put this up on the board and ask students how many solutions are there, the typical answer that I often get is that you cannot solve for that. Okay, so, and that's a dangerous answer. And I say it's dangerous because it is indicative of the fact that there is something wrong in your foundations. Okay, there's something deeply incorrect about your understanding of equations and what a solution means. Okay, so let me take this opportunity to rectify that. Okay, so first, let us revisit something very fundamental. Solution. What do we mean by a solution to an equation? So let's take that simple case, 3x equals 5. Okay, x equals 5 by 3. So what does it mean to say that x equals 5 by 3 is a solution? What it means is that if we take this number 5 by 3 and plug it into this equation in the place of x, then the equation holds for this particular value of x. The two sides match. Okay, when we plug in x equals 5 by 3, 3 cancels out. We have 5 on the left hand side, and of course we have 5 on the right hand side. So the equation balances. It holds for this value of x. So that's what a solution means. Not just for this equation, but for any equation. So for this equation, if we can find a value of x and a value of y, that would make this left hand side equal to 12, which is the right hand side, then we would say that we have found a solution. Okay, and such solutions are not hard to find, right? Just by inspection, you can tell that if we take x to be 3 and y to be 2, then the left hand side becomes what? 2 times 3 plus 3 times 2, it becomes 12, right? So x equals 3, y equals 2 is a solution. Nandini, it's very important that you understand this.
Yeah.
Let me move over to the right, so you can see this clearly. It's very important. It's critically important that you understand this. Okay, because what I'm talking about is something very fundamental. There's no rocket science going on here. I'm trying to explain to you what the solution to an equation means. Okay, what does it mean for an equation to have a solution? Are there any questions at this stage? And this goes out to Nandini in particular. Is that clear?
No. Yeah, this is clear.
Okay, so that's a solution. Now, how about other solutions? Are there other solutions? Of course. Okay, so let's say we take x to be equal to 0. Okay, let's just make an assumption that x is 0. Now, if x is 0, then 2x becomes 0. Then the question is, what does y have to be so that the two sides balance? So if x is 0, this is gone. So we are left with 3y equals 12. So if we choose y to be equal to 4, then the left hand side balances the right hand side, matches the right hand side. So x equals 0, y equals 4 is a solution. And this has to do with the definition of a solution. Definition of a solution is any value that you assign to the variables that make the two sides balance out. Okay. What if we took y to be equal to 0? If y is 0, then this term disappears and we are left with the term 2x. Then the question becomes, okay, so what should the value of x be so that 2x becomes equals to 12? What should the value of x be? It should be 6.
6. Yeah.
So x equals 6, y equals 0 is also a solution. Okay, so now notice we have identified 3 solutions. Okay, so now, you know, I'm directing this comment particularly at Vidushi. So as you can see that this equation, what you said was incorrect, that it has 2 solutions. We were able to identify 3 solutions. But now if you notice something interesting about how we were identifying these solutions, well, the first one, it kind of felt like I pulled a rabbit out of a hat, but there was a method in which we identified these 2. All we did was we picked a value of x equals 0. And correspondingly, we asked ourselves what should be the corresponding value of y so that the 2 sides match. To identify this solution, we assigned a value to y. We said we just assume y to be equal to, we didn't assume so much, we assign the value 0 to y. And we asked ourselves correspondingly, if y is 0, how much should x have to be so that the 2 sides balance out? And the answer we got was x equals 6. So as you can tell, using this scheme that we used to identify these 2 solutions, okay, we can identify more solutions, can we not? So what's a systematic way of exploring these solutions? So this is a systematic way. You make a table, x and y, okay, and you assign different values to x. Say x is 0, okay, correspondingly y would have to be 4. What if x is 1? If x is 1, then 2x is 2. So 2 plus 3y equals 12. That's what the equation reduces to. So 3y becomes, when you take the 2 over to the right hand side, 3y becomes equals to 10. So y becomes equal to 10 by 3. That's another solution. X equals 1, y equals 10 by 3. Then what if we pick the value 2 for x? Then 2x becomes 4. So we have 4 plus 3y is equals 12. So 3y becomes equal to 8. Okay. So if y is 8 by 3, corresponding to the value 2 that we assign to x, then the left hand side becomes equals to 12. Okay. And in general, just to make the calculation of these y values simpler, what we can do is we can use this equation to identify y in terms of x. Okay, so a simple transposition of the 2x term over to the right, okay, and then would show that y would have to be, what does y have to look like? If I write y in terms of x, what does y become? It becomes 12 minus 2x over 3. Okay, so if we pick any value of x, and correspondingly if we pick a value of y according to this rule, then the value of x and the value of y, the value that we assign to x and the value that we calculate for y would qualify as a solution to the original equation. Okay, it will balance the original equation. Why is that so? Because this equation, using which we are identifying values of y corresponding to various values that we assign to x, this equation is identical to this equation. They're the same equations. Okay, anyhow, so using this scheme we can identify several solutions to the given equation. So now if I'm to ask you how many solutions does this equation have, what would your answer be?
So then would it be infinite?
Infinitely many solutions, right? Nandini, you see that?
Yeah.
because we can assign any value to x. So, in theory, we can assign infinitely many different values to x, and correspondingly we'll have, some value of y according to this rule, which is equivalent to this rule, such that the two values of x and y would balance the given equation. It will make the equation true. Okay. Now, having said that, does this look familiar to you, this whole exercise? You have seen this before, have you not?
Yeah.
In what context? Where have you seen this?
We've done this at school just as
In
part
school.
of
Okay. So let me rephrase my question. So once you did this exercise, what was the next thing that you did?
We went on to polynomials and more complex forms of this.
No. I'm not talking about that. Like after you identify these pairs of solutions, just that you were not, unfortunately, often teachers do not emphasize the fact that this this exercise, what this the result of this exercise, or the outcome of this exercise is identifying solutions to a linear equation having two unknowns. Okay, so once you did that, you created a graph of this equation, did you not?
So we usually solved for y to get the equation in the normal form, in the standard form, as in like y equals to mx plus b. And once we got it into that form with the y isolated, it was much easier to graph. So
Yeah.
that's what we.
I mean, that's one way of doing it, but this is also another way of doing it. Okay. So basically, after you did this, so this is really written in the form y equals mx plus b, if you think about it. Okay, because this is 12 by 3 minus 2x by 3. So that's b plus mx. Okay, it's in that form. But what I was trying to say is the next step generally is, what you do is you plot this point on the xy plane. X is 0, y is 4. So that gives you a point, okay, on the xy plane. And then 1 and 10 by 3. So 1 and 10 by 3 would be somewhere over here. And then 2 and 8 by 3 would be somewhere over here. And then you join this, and that gives you the graph of this equation 2x plus 3y equals 12. Okay, so far so good. This is something you've seen before,
Yeah.
right? Okay, so you have done this mechanically, but now it's time to understand what's going on here more deeply. Okay, so point number one that I wish to emphasize, as a summary of everything that we saw so far, is that this equation, not only can it not be solved, there are solutions to this equation exist with a passion. Okay, there are infinitely many of them. Point number one. Point number two, when you take these solutions, okay, considering them as ordered pairs, 0, 4, 1, 10 by 3, 2, 8 by 3, when you take these solutions and plot them on the xy plane, you get a straight line. Okay, which is why such an equation is called a linear equation. Okay, because the graph is always a line. Okay, the graph of such an equation. General form of it is, of course, ax plus by equals c. Okay, that's the general form of a linear equation in two variables where a, b, and c are constants. So you always get the graph of a straight line. And another thing to bear in mind, and this is often overlooked, in a high school curriculum. It's not always explicitly mentioned. Didn't happen in your case. These points that constitute the graph of this line are nothing but solutions to this equation. That's the thing to bear in mind. Okay, so a graph of an equation. Okay, I've run out of space, but I'll let you write this down. The graph of an equation. Well, let me actually, it's worthwhile for me to write this down. Let me erase some of this stuff. So let me articulate what I'm about to write down. It is that the graph of an equation is a collection of points x comma y, okay, such that these points, these x values and these y values are solutions to the equation. So a graph is a collection of points that are solutions to this equation. Each point has an x value and a y value, naturally, like any point would have a x value and a y value attached to them. And these x and these y and these x values and these y values are the solutions to the equation. Okay, so we could say the graph of 2x plus 3y equals 12 is a collection of points x comma y on the plane such that x and y are solutions to the equation okay. So this is a very key idea. Okay, so please take this down. And are there any questions at this point?
No.
Okay, so I would like to think that there are two myths that I busted. One myth is that this cannot be solved. Okay, so as we saw that no, not only can it not be solved, there are infinitely many solutions to this equation. So so that's one myth that I busted. The second one was not so much a myth that I busted, but rather a clarification that I would like to think that I provided, and it is that what's the graph of an equation? Okay, so first we talked about, we tried to get some clarity around the idea of solutions to an equation. What does the solution to an equation mean? Now let's talk about what does the graph of an equation mean. It's nothing but collection of points on the xy plane, okay, such that the x coordinates and the y coordinates of these points taken as a pair, okay, when you plug these x values and these y values in the equation holds true. Okay, so that's the graph of an equation. Any equation, it doesn't have to be a linear equation. It can be something very complex. So for example, let's take this as an example. X squared plus y squared equals 1. Okay, so I'm sure you have come across this. Okay, so what's this? Like if we plot the graph of this, what does it look like?
It's a quadratic again.
Can you be more specific? Actually, it's not really quadratic, because for it to be a quadratic, one of the variables can have a square term in it, but the other one should be free of a square term. Okay, this is the graph of this is the unit circle. Okay,
No, sorry. Oh yeah, my bad. Sorry.
right?
I wasn't thinking. Yeah.
Okay, no problem. So this point passes through, the graph passes through these 4 points. Okay, now the thing is, if you pick any point on the unit circle, okay, so some x naught, y naught, and if you plug in x naught in place of x and y naught in place of y, the equation balances. Okay, so what would be an example of such a point? It would be 1 over root 2, 1 over root 2. Okay, which would be pretty much, like, this point, if this is one, it will be pretty much located here. Okay, exactly. If you take 1/4 of this arc, it will be halfway, located halfway on this arc. Okay, so this is also, see, this is also an equation. This is also an equation, and this is a solution to this equation. Okay, so to straighten things out, to say it correctly, this is an equation that we are given using the same method, by creating an x table and a y table, and by assigning different values to x and calculating the corresponding values of y. we will be able to identify infinitely many solutions to this equation. Okay, so for example, if x is 0, then notice how much does y have to be? Y can be +1 or -1, right? If x is 0, so y could be 1 or y could be -1. Okay, if x is 1 by √2, then we have half plus y squared equals 1, right? If x is 1 by √2, then if we plug in 1 by √2 in place of x, then x squared becomes half. Half plus y squared equals 1. So y squared becomes equal to half. And solving that, we get y equals 1 by √2 or y equals -1 by √2. Okay. So now if we take these points, okay, if we take these points or take these x and y values and plot them on the xy plane, then we would notice that these solutions when plotted on the xy plane gives us a circle. Okay, pretty neat when you think about things that way. So this is my equation, these are the solutions, and when I plot them, I would notice that these solutions are arranged in a circular format. Okay, so the plotting, when you plot these solutions out, what you obtain is the graph of the equation. Okay, so for example, 0, 1. 0, 1 is this point. 0, -1 is this point. Okay, 1 over √2 is this point. 1 over √2 minus 1 over √2 is somewhere over here. Okay, it's simply the reflection of this point across the y-axis. Across the x-axis. Okay, so this idea of the graph of an equation as constituting the collection of all solutions to this equation, it's a universal idea that applies for all equations, all kinds of equations. Okay, be it a linear equation or be it an equation of this form. Okay, are there any questions at this stage? Hello, any questions?
No.
Okay, wonderful. So let's move on. But I tell you what, this thing that I wrote down and also some of these ideas that I mentioned in this class, it's important for you to go back to these ideas. Keep going back to them frequently, okay, till it becomes, because see, basically, as I mentioned, at the very beginning, both of you were, Vidushi, you were not entirely clear about how many solutions this has. And with Nandini, I would say that there was a fundamental, error in your understanding of what the solution to an equation means. Okay, so these are like, very foundational, what should I say, foundational ideas in mathematics about which you must have total clarity. Okay, so that's why I would ask you to keep going back to these ideas. So what we are going to do next is, and Nandini, there's also a reason. I even know why you said that it cannot be solved. And why is it that, as I mentioned, many of my students, when they see 2x plus 3y equals 12, and I ask them how many solutions there are, there's a reason why we get this popular response that it cannot be solved. Okay, so we are coming to that. What we'll do as a next step is, we'll take this equation, 2x plus 3y equals 12. Okay, and along with that, let's consider another equation, x minus y equals 1. Okay, and now, just as this has infinitely many solutions, even this has infinitely many solutions, as you would imagine. Okay, you assign various values to x, correspondingly you're going to get various values of y. Okay, and y, as you can tell, y has to be 1 less than x. Okay, so if x is 3, y has to be 2. If x is 18, y has to be 17. Okay, and in all these cases, as long as y is 1 less than x, the equation will hold. So again, this has infinitely many solutions, just as the first one. Okay, but now a question that we often ask is, before the question, we consider this as a system of equations. So in other words, we are no longer considering these two as standalone equations. Okay, so you have to understand the distinction between, you know, these two equations considered as standalone equations and these two equations considered as a system. Okay, so when we consider these two equations as a system, it is also possible to ask, okay, it's also possible to talk about solutions to the system. Okay, so let's try to understand. We understand what solution to this equation means. Okay, we also understand what solutions to this particular equation, what it means. X and Y values that make this true, X and Y value that make the first equation true. When we are talking about solutions to this system of equation where both these equations are being considered collectively, okay, we mean some value of X and some value of Y, say X equals X naught and Y equals Y naught, for which both these equations hold true simultaneously. Both these equations hold true simultaneously. Okay, so I'm sure in high school, you know, you have seen several such instances where you were given a system and you were asked to solve for the system. Okay, and in the context of working out these problems, somehow, and this unfortunately happens to a lot of students, as in Nandini, somehow you are given the idea that if you have only one such equation, you cannot solve, you know, for that equation. You need two to be able to solve it. But you have to understand here. So again, so let me provide you with the correct perspective, the correct way of looking at things. As standalone equations, either one of these has infinitely many solutions. As a system, usually your experience would tell you that they have a unique solution. They have a unique solution, which you can calculate, you know, using the usual, like, you know, manipulations, substitution, and then there's elimination, you know, either one of those tricks. And you would in fact notice that for this particular system, X equals 3, Y equals 2 happens to be the solution. Okay, so this is the, because see, we already saw that 3 and 2 make the first equation hold, and naturally, as you can tell, 3 and 2, X equals 3, Y equals 2 also makes the second equation hold. Okay, so X equals 3, Y equals 2 is a solution to the system. So we have to make an important distinction here, the distinction between solution to this equation when considered as a standalone equation, solutions to this equation when it is considered as a standalone equation, and solution to both these equations when they are considered collectively as a system. So when they are considered as standalone equations, each has infinitely many solutions. When considered as a system, usually it is the case that they have only one solution, and which is something, you know, you have done plenty of times. You know, solve such system, you know, plenty of times, and you were always able to find a particular solution to the system. Okay, are there any questions at this stage?
No.
Okay, all right. Welcome question, because, you know, these are like really foundational ideas. Okay, so let me write this down. Okay, so as standalone equations, they have, each has, let's put each has, as standalone equations, each has infinitely many solutions. As a system, they have only one solution, x equals 3, y equals 2. And this is again extremely important. I meant to underline this, standalone system. Extremely important idea. So next time, you come across this, along with the question that can this be solved? Yes, absolutely. It can be solved infinitely many solutions. Likewise for the second equation. Can the system be solved for? In this case, yes. How many solutions does it has? One solution. Okay. Okay. So now my next question for you would be this. Now see this x equals 3, y equals 2, you can solve this in the usual way. You're going to find x equals 3, y equals 2. And as we even check for ourselves, if we take these two values and plug them in place of x and y in either of these two equations, they hold for x equals 3, y equals 2. So it is a solution. Now, is it possible? This is my question now. Is it possible that this system has more solutions? I mean, we do that, usual routine algebraic, if you take yourself through that usual routine algebraic process of solving for the system, you do get this solution. But how can we be entirely sure that this system doesn't have other solutions, which may require other, advanced algebraic techniques to identify? It's possible. Can we be sure? Could it have more than one solution? What do you think? Now see, the answer to this question, okay, both of you are quiet. So, all right, let me elicit a response. What do you think? What do you think? It's okay to be wrong. It's okay to be wrong. But what do you think? Could it have other solutions? Or is this the only solution? Any response? Hello?
I think it's possible because at one point both of them are linear, right? So at one point in the graph, both of them will intersect, and that's the value for which both the equations are equal.
I tell you what, I quite welcome your answer, because see, I'll tell you one thing. Given everything that you have seen so far in high school, there's actually no straightforward way of telling whether this is the only solution or not. There is no straightforward way of telling. Now, it turns out that this is the only solution. Having said that, the reason I said that, your answer was, it's a valid response of sorts, because there's no telling that whether it will have more solutions or not. Okay. We know for sure that this is one solution, but does it have more solutions? Okay, so this is the topic that I wish to take you through. Okay, as I told you, that this system actually has a unique solution. It doesn't have any other solutions. Okay, how can I tell that? Okay, so what are the criteria that enable us to tell whether a system has a unique solution or not? Okay, so that would be actually the, it's a topic that's very much a part and parcel of SAT. It's overlooked in most high school curricula. So I'm going to teach you about that. Okay. So at this stage, you can take my word for granted that this system actually has a unique solution. Okay. But, this also raises the question, when I say that this system has a unique solution, it raises the question that is it possible for a system to have more than one solution? A system, mind you, of course, individually, these equations have infinitely many solutions. So we are not going there. We're talking about a system. Is it possible for a system to have infinitely many solutions? Is it possible for a system to have no solutions? Okay, now see, the systems that you came across in primary school, in high school, okay, for the last few years, they all had a unique solution, because, given such a system, you were able to solve for x, solve for y. You got one value for x and one value for y. So those examples that were given to you, okay, examples of systems for you to solve, Okay, those examples were doctored. Okay, they were examples that always, like it was, the teacher ensured that there would be a unique solution such as this to those systems. But in general, okay, it is possible for a system to have no solutions. Okay, so let us see when does a system, so let's do something. So this is a solution to the system, and we could state that in fact it's unique. The solution is unique. Now let us take an example when an equation would have, a system would have no solution. Consider 2x plus 3y equals 12. The first equation, we are keeping it unchanged. And for the second equation for the system, let's consider 2x plus 3y equals 7. So again, this has infinitely many solutions when considered as a standalone equation. So does this. Now consider them as a system. Okay. Consider them as a system. Now this system has no solutions. There you will not be able to come up with a value of x and a value of y that would make both of them hold simultaneously. That's not going to happen. Do you see why? Okay, that's my question for you. Can you see why? Because if x equals x naught, y equals y naught were a solution, then what would happen? If that were a solution to the system, mind you, to the system, then these two values, x naught and y naught, have to make the first equation true as well as the second equation true. Okay. Then twice x naught plus 3 times y naught must be equal to 12. And twice x naught plus 3 times y naught has also to be equal, has to also be equal to 7, where x naught and y naught are two specific numbers, two specific values. So now can you see why this is impossible? Because these two are clearly the same. X naught is a specific value, y naught is a specific value. So this is a specific value, and so is this, and these two are identical. Now this number, it's a number because x naught and y naught have specific values, are two specific values. So this number cannot be equal to 12 as well as 7 at the same time, right? You see that?
Yeah.
Okay. I just heard one yeah. I'm looking to hear another yeah. So Vidushi, was that you who responded with a yes?
Sorry, it was me. Nandini.
Nandini. And Vidushi, does this make sense?
It does make sense, yeah.
Okay. So basically, see, now this system, such a system that has no solution. Let's first talk about, like, just very qualitatively what such a system has to look like. Pretty soon we'll be, I'll be providing you with more explicit rules that will enable you to determine, okay, what such a system that has no solution, how to identify such a system. Okay. But roughly speaking, see, if I wanted, I could have also chosen the first equation as is, 2x plus 3y equals 12. And I could have chosen, instead of choosing 2x plus 3y equals 7, I could choose twice that much. Okay, I could multiply through with 2, both the left hand side and the right hand side. So that would give me 4x plus 6y equals 14. Okay, so this system is equivalent to this system. Okay, so even this doesn't have any solution. Okay, so to be able to tell whether a system has no solution, what you need to do is you need to take the constant terms over to the right hand side and then simplify the left hand side. Okay, so here there is not much simplification to be done, but here of course you can divide through by 2. Okay, and that will give you 2x plus 3y equals 7. And at this stage the left hand sides for both would look identical. So whenever okay, it is possible to take the two equations of a system, okay, and by moving the constants only to the right hand side, whenever it's possible to write the left hand sides in the same form. When the left hand sides have the same form, but these two constants are unequal, system will have no solution. Okay, so just bear that in mind. So we have seen two possibilities so far. A system may have a unique solution, which is something that you have seen, like, you know, seen loads of such examples of such systems. And the second possibility, where a system doesn't have a solution. Okay. Now there's a third possibility. It is that a system may have infinitely many solutions. Infinitely many solutions. Let's see an example of such a system. So for the first equation of the system, we again, you know, we can choose 2x plus 3y equals 12. For the second candidate, you know, for this system, what we do is we can have any equation in place of the second equation. So what we choose to do is we just take a multiple of this first equation. So let's say we multiply both the left hand side and the right hand side by 2. Okay, so that gives us 4x plus 6y equals 24. And let's say that's our system. Okay, now notice, although we are calling it a system, effectively we just have one equation in the system, because this is repetition. This equation is equivalent to the first equation. Not equal, they're not the same because the coefficients are different. However, they're equivalent in the they're equivalent in the sense that both have the same sets of solutions. Both have when considered as standalone equations, that is, both have infinitely many solutions, of course, and these two infinite sets of solutions to the first and the solutions to the second equation exactly match. Both have, I should say, the same set of infinite solutions. Because if there's a value of, you know, if there's a value of x and a value of y that makes the first equation true, okay, say x equals x naught and y equals y naught, makes the first equation true, then it would make the second equation true. So if there's a value of x, say x naught, and a value of y, say y naught, that makes the first equation true, then simply by multiplying this equation both sides by 2, we get 4x naught plus 6y naught equals 24, which implies that this same value x naught and y naught also makes the second equation true. And vice versa, as you can see, you know, if x naught and y naught make the second equation true, then by dividing by 2, we would get 2x naught plus 3y naught equals 12, which goes on to show that x naught and y naught also make the first equation true. So they have the same sets of solutions, and this particular set of solution, which is identical for both these equations, is infinite. Okay, so the system has infinitely many solutions. Okay, any questions on this?
No.
Okay,
No, it's fine.
so remember, so this is the summary. A system of two linear equations in two variables may have one, none, or infinitely many solutions. That's our key learning. Okay, one, none, or infinitely many. Oh, and another thing, for a system to have infinitely many solutions, as you can tell from this by looking at these two equations, one equation has to be an exact multiple of the other equation. Okay, So what that would mean is these coefficients, they must have the same ratio. 2/4 is half, 3/6 is also half, 12/24 is also half. So that gives you a criteria, in fact, a criteria in terms of the coefficients of, the two equations in the system, a criteria that tells you, whenever that criteria holds, namely that the ratio of the coefficients as well as the constant terms is identical. When the ratios are identical, the system has infinitely many solutions. So whenever you see that holds for a system, you would conclude that it has infinitely many solutions. Now, correspondingly, there's also a criteria that tells you when does an equation have a unique solution, okay, which was the first example we took up. 2x plus 3y equals 12 and x minus y equals 1. And you have seen plenty of such examples in your school, as you solve for these systems. They all had unique solutions. So there's also criteria for that. So what we are going to do as a next step is we are going to derive these criteria. And this is all in the context of VCT. So this is something that you need to know. Okay. So I tell you what, so I realized that I've already taken about an hour, and I believe there was plenty of new learning that you underwent. Okay. So to derive these criteria, it's going to take me like another 20-25 minutes. Are you good to go for another 20-25 minutes? That's my question to you. Should I continue or?
Yeah, that's fine.
That's fine. Okay. Wonderful.
That's okay.
Okay. All right. So now the derivation of these criteria, it's rather interesting, because what we are going to do is we are not going to take an approach that's based on algebra, although this is, this topic lies at the heart of algebra. But it turns out that the derivation, so actually one reason why I personally, and when I was your age, I came across this derivation, I was fascinated. The whole reason is we take a very geometric approach, coordinate geometry to be more specific, okay? So to derive the criteria. So this is the topic that, that I was reluctant to describe at the very beginning of this lecture. Conditions under which a system of two equations in two variables, but it could actually be, n number of equations in n variables. The conditions are can be it is true that you may have n number of equations in n number of variables. These are the only three possibilities. Okay, as long as the systems are linear, of course. Okay, one, none, or infinitely many solutions. And so anyhow, so as a next step, conditions under which a system of two linear equations in two variables have one, none, or infinitely many solutions. So we are going to identify these conditions. Okay. Now the way we are going to do it, as I mentioned, we've taken an approach from coordinate geometry. So this is what I mean. So let's say we have a system a1x plus b1y equals c1, a2x plus b2y equals c2. Okay. And let's take the first equation in this system. As we saw, it has infinitely many solutions. As we also saw, when we take these solutions and plot them on the coordinate plane, we get a line. Okay. So this line, the points on this line represents, well, this line is the graph of a1x plus b1y plus c1, and each and every point on this line, if it has a x value and a y value, that constitutes a solution to this equation. So likewise, a2x plus b2y equals c2. a2x plus b2y equals c2. Okay. there's a graph corresponding to a2x plus b2y plus c2 such that each and every point on this graph is a solution to this equation. Now, with that idea at the back of our heads, that any point on this line has an x value and a y value, that makes this hold, makes this equation hold, is a solution to this equation. With that idea at the back of our heads, let us ask ourselves, and it's really a question to you, what can we say about the point of intersection of these two lines? What's so special about it? It lies on both lines. Therefore, what do you think?
A plane?
Hmm?
No, I'm not sure. Sorry.
So let's say its coordinates are x0, y0. Then if I plug in x0 in place of x and y0 in place of y, in this equation, in the first equation, that equation will hold because it's a point on the graph of the first equation.
Yeah.
And since it is also a point, the point of intersection is also a point on the graph of the second equation. If I plug in x equals x0, y equals y0 in the second equation, it will hold.
Yeah.
So x0 and y0 are, what's the name? What can we call them? What do we call them? It's a solution to the system. It's a solution to the system. Right?
Yeah.
Okay. Are both of you okay with that? I just heard one voice.
Yeah.
Yeah,
That was Vidushi's voice. Nandini, clear about that?
yeah, it's clear.
Okay. So that's the solution to a system. Okay. Now, two straight lines. How many points can they intersect at? Only one point. Only one point. So that goes on to show that for most systems that have a solution, like generally speaking, for this setup, when you plot the two plot the graphs of the two equations of the system, and you get a setup like this, there can be only one solution. Okay. So this is one possibility, like graphically, as you can see. Okay. So this is one possibility. The other possibility is for a system to have no solution. So let us see, if a system has no solutions, then what do the graphs of the two equations of that system look like? Okay. Now, as you can,
Parallel lines.
parallel lines, wonderful, wonderful. Because the moment the two lines that represent the graphs of these two equations, the moment they intersect, we have a solution. Okay, we have a solution. So no solutions would imply a situation such as this. Okay, where these two, so let's call this L1 for line 1 and L2. Well, the equation 1 and equation 2, correspondingly we have L1 and L2. The graphs of the two equations, let's refer to them as L1 and L2s for line 1 and line 2. So if they're parallel, then they're not going to intersect. Okay, and we will have no solutions. Okay, and now for the third possibility, infinitely many solutions. Now this
Overlap.
happens, yes. Yes.
They're one on top of the other.
One on top of the other. Wonderful. Who was that? That was Vidushi. Okay.
Yeah.
So one on top of the other, which is again like algebraically, we saw infinitely many solutions happens when one line, one equation is a multiple. It's a constant multiple of the other equation. So the underlying solution sets are the same. And the collection of these solution sets is the graph of the equation. So both equations have the same graph. Both the lines, they are identical. So infinitely many solution would mean this is L1 as well as L2. Okay, one line is on top of the other, and each point on this line is a solution to this equation. Okay, so now with this backdrop, what we can do is we can identify the criteria for an equation to have unique solution, no solutions, or infinitely many solutions. Okay. So to do that, let's first talk about unique. Well, before that. Okay, let me put this unique solution. Now, for a line to have unique for a system to have unique solution, the two lines must intersect. And when do they intersect? For them to intersect, they have to be non-parallel. If they are non-parallel, they would intersect. Or in other words, they must have different slopes. Okay, why don't I do something? Let me put the picture up here. So this is the picture corresponding to a system having a unique solution. So if they have different slopes, what does slope measure? Slope measures inclination as well as steepness, but inclination too. Inclination of a line with respect to the x and y axis. So when these two inclinations are different, when the slopes are different, then the two lines are bound to intersect at a unique point, which constitutes the unique solution to the system. So now to derive the algebraic criteria, okay, based on these coefficients that tell us when a system would have a unique solution, it's rather easy. So for this particular, for the first equation, notice that the slope which we call m1 would be equal to what? Minus a1 by b1. All you have to do is write this in the slope intercept form, y equals mx plus b. So minus a1 by b1, and the y intercept would be c1 by b1. Okay, please interrupt me and let me know if that's not clear. Okay, all I did was, like, I mean, just mentally, I just like shifted a1x over to the right, divided by b1 to rewrite this in the slope intercept form, y equals mx plus b, from which it should be clear that the slope is minus a1 by b1 and the y intercept is c1 by b1. And for the second equation, the slope is minus a2 by b2 and the y intercept is c2 by b2. Okay, any questions on that? Is that clear? Is that part clear?
Yeah.
Okay, so now unique solution would imply that slopes are different, which would imply minus a1 by b1 is different from minus a2 by b2, which would imply, and there's a reason why I do this. All I do is I interchange these terms to rewrite this inequality, or this, no, I shouldn't say inequality, non-equality, as a1 by a2 not equal to b1 by b2. Okay, so a1 by a2 is not equal to b1 by b2. So when you see a system, when you are given a system, to be able to tell if it has a unique solution or not, all you have to do is find the ratio of the coefficients of the x term and the coefficients of the y term and make sure that they are not identical. Okay, so let's say we wish to generate an example of such a system. How can we do that? So let's just take the first equation to be 3x plus 4y equals 7. Okay, so let's say so now all we have to do is implement this criteria on this system to ensure that we have a system that has a unique solution. So let's multiply 3 with 2 to get 6x. So as long as we multiply 4 with a number different from 2, it can be anything, it could be 3, which gives us a 12y, we will have a system that has a unique solution. And again, this can be times anything. Okay, so we can take it 14 if we like. Okay, so as long as these two are different, these two have to be different. Okay, we are assured of finding ourselves a system that has a unique solution. Okay, so that's the criteria, remember that. Any questions? Okay, so now let's take the second case. No solutions. So what's the picture corresponding to the no solution case. The two lines are parallel, but not coincident. They're parallel, but not coincident. So what does that mean? It means that they have the same slopes, but different y-intercepts. So no solutions would mean slopes are the same, but the y-intercepts are different. So if slopes are the same, then minus a1 by b1 is equal to minus a2 by b2. And if y-intercepts are different, then c1 by b1 has to be different from c2 by b2. So just by rearranging these terms a little, so that we have ratios of the coefficients of x, the coefficient of y, and ratios of the constant terms. So just by rearranging this, we could write this first criteria as a1 by a2 equals b1 by b2, and b1 by b2, we can take the b1 at the top, bring the c2 at the bottom by cross multiplication. b1 by b2 is not equal to c1 by c2. So now we can obviously put these two together, which gives us the criteria for a system to have no solutions. a1 by a2 equals b1 by b2, which is not equal to c1 by c2. Okay. Any questions?
No, it's fine.
Okay. Give me just a second. Okay, there's been an issue on my mobile phone. So I'm like woefully short of charge. So I'm kind of worried that I might get disconnected. Like, maybe I can go on for another 5 minutes or so, but then that should give me enough time to conclude this topic. Okay. So if we wish to generate an example of a system that has no solution. So let's say we take 3x plus 4y. We can take the first equation to be most anything. And then we just need to make sure that the x, the coefficient of the x terms and the coefficient of the y terms are identical. So we can choose to multiply 3 with a 2 to get a 6x, in which case we have to also multiply 4 with a 2 to get a 8y. And this, for this term, it cannot be times 2. It cannot be times 2 because notice, while a1 by a2 has to be identical to b1 by b2, either of these two ratios have to be different from c1 by c2. So in this case, a2 is twice a1, b2 is twice b1. So 7 has to be times anything other than 2. Other than 2. Okay, so we can take it to be a times 3. We can take it to be a times 3. Okay, so this gives us a system that has no solutions. And sure enough, we can rewrite this in the following way. We can rewrite the first one. Suppose we were given this, we rewrite the first equation as is, and the second equation we can divide by 2 to get a 3x plus 4y equals 21 by 2. So now we have this situation where the left hand sides look identical, but on the right hand side you have two different constant values, and there is no value x naught for x and y naught for y that would make the two equations hold true simultaneously. And now for the third criteria. When does an equation have infinitely many solutions? So when this happens, graphically, the two equations, they line up, L1 and L2. So that means slopes are the same and y-intercepts also the same. So the slopes were what, minus a1 by b1? I think I erased that. Yeah. So minus a1 by b1 equals minus A2 by B2. And the y-intercepts are the same, meaning C1 by B1 is equal to C2 by B2. So again, by rearranging these terms, what do we get? This tells us A1 by A2 equals B1 by B2. And this is telling us B1 by B2 equals C1 by C2. So we can combine these two. B1 by B2 equals C1 by C2. Okay. So these are the three criteria. So I think that's a good place to stop. Although, like, you know, I mean, we could like work out a few examples, but, you know, it's been a rather long lecture already. So there are, you know, I won't say that, you know, like you are frequently asked questions on this topic in SAT, but there are, you are asked questions on this topic. So it's important for you to know these criteria. Okay. So I think I'll stop here for today. And if there are any questions, please, you're welcome to ask me. Any questions?
No, no questions.
Okay. So what I would like for both of you to do is, I would like to think that there are some foundational, you know, like mathematics that I clarified for both of you today. You know, the idea of the solution to a system of, you know, solution to a standalone equation. The difference between the solutions to a standalone equation versus the solution to equations considered collectively as a system. That's an important distinction. Okay. And then, of course, you know, these three possibilities of a system of linear equations in two variables having one, none, or infinitely many solutions. So it's important that you know these distinctions and you know this criteria. So what's really cool about this mathematics, in my opinion, is that we are actually using tools from coordinate geometry to establish algebraic criteria that pertain to the system of an equation. Okay, so we have an algebraic problem really. They're given two equations, a1x plus b1 by y equals c1, a2x plus b2y equals c2. And the challenge is to find conditions based on these coefficients that will tell us when does this equation have one solution, when it has no solution, when it has infinitely many solutions. So we take this algebraic problem, translate it into the context of coordinate geometry, and we get answers, you know, in the context of coordinate geometry based on the idea of slopes and, you know, y-intercepts. So I think this is quite fascinating, and in advanced math is full of, you know, such situations where you take, you know, an algebraic problem, translate it into a geometric context, and then, you know, the solution becomes very accessible. Okay. Okay, good. So, Brotin, you want to?
No, I want to add a word, sir.
Please.
So with your permission.
Sure.
Yeah, Brotin has taped out. So all of the concepts you learned today will be relevant, students, to practical questions on the SAT which sir will offer the last. Okay. So if you do decide to join, all the materials will be provided, all the past tests and everything, and our material, as SAT sir has stressed time and again, are based on actual real SAT questions. Okay. So that will be it. Please do let us know your feedback about the class and about the demonstration classes. Any questions? Students?
No, no
No,
questions.
it's okay.
No questions?
All right.
Okay.
So,
Thank you. Okay.
enjoy the rest of your
Bye.
day. Enjoy your weekend.
Yes.
You too.
And
Thank
it's time for lunch. Bon appetit. Bye-bye. Oh.
Thank you.
Bye-bye.
Bye.
Bye-bye. It's lunch hour in Singapore right now. We have been keeping you for a very long time. Bye-bye.
That's okay. Thank you.
Have a nice
Bye.
day. Bye-bye. See you soon.
Bye.
Bye. Bye.